So now if you look into more questions, better questions, so first of all in AP, let's say there's three numbers A, B, C. So 2B equal to A plus C. So A plus C is even. So that means it's either an odd or even right. So if you look at case 1, if n is even, then there are n by 2 even numbers and n by 2 odd numbers. Just select 2 from this, so it's n by 2 C2 plus n by 2 C2. If n is odd, then n minus 1 by 2 even or even numbers and n plus 1 by 2 odd. So again just write that. That's the answer. So if it's for evens, the answer. If it's odds, the answer. So there's a word given, history. Right. Now, first is listing HIS always together. So you can take this as one group, right? So that will just be, and you have to displace in how many ways? 1, 2, 3, 4, 5, 6, 7. Okay. 2, 3, 4, 5, 6, 7. Where we take HIS as one group. So it's 5 factorial ways and 3 factorial inside how you can move the HIS. Right. Now if you look at B part, it starts with H and with Y. HISTOR. What 5 factorial things you can put there? Okay. Next is start with H or end with Y. So let's take the case where it's starting with H. So that's 6 factorial plus, let's say it's ending with Y. And that's 6 factorial. Now you have to minus the case where it's starting with H and ending with Y, which is 5 factorial plus 2 into 6 factorial minus 5 factorial. Next case is neither starts with H nor ends with Y. First of all, total case is 7 factorial minus either starts with H or ends with Y, which we have done before. find the position of the word tough if all are arranged in alphabetical order. So first what you do in this question is you write it in alphabetical order, like start from the beginning. So it's GHOTU, right? And you start from a G. If you put 1, 2, 3, 4, 4 factorial, H 1, 2, 3. Also you have 4 factorial. Then comes T. So I take T and we take G, 3 factorial, and take T and take H, 3 factorial. Now we take T, O, right? And again we take G, 2 factorial. This G we can take till U part, right? H also is 2 factorial. T, O is gone. H, okay, we did. Now hence the word itself which is remaining, which is tough, 1. So you just add all of these, you'll get it. It's 89. Same way you can do. Next question is, out of 5 boys and 3 girls, a committee of 3 is to be formed. So number of ways to form it. Which contains at least 1 girl. So obviously there are 2 methods for this. Method 1 is total minus no girl. So that's 8C3 minus 5C3, right? Because out of 8 and choose 3, anyone, give me anyone. Minus when choosing only the boys, that's 5C3. Method 2, I'm going to say at least 1. So you can make cases for exact 1 plus exact 2 plus exact 3. So that is 3C1 into 5C2, 3C2 into 5C1 plus 3C3. Next question is, there's 16 players. So out of which 4 bowlers, 2 wicket keepers and 10 batsmen. We want to make a team of 11 players, obviously, such that I have at least 3 bowlers and at least 1 keeper. So at least 3 bowlers. So let's take case we have exact 3 bowlers. So that's 4C3. Now in that we can make cases for the wicket keepers. So let's say exact 1 wicket keeper. Now batsman, I can choose 10C7 plus let's say you choose exact 2 keepers. So it's 10C6. Now let's say you take exact 4 bowlers. So then again you do the same thing what you did previous, except like take in the case that you took an extra for bowling. next question. And there's a conference and there's 10 speakers. S1 wants to speak before S2 and S2 after S3, right? The number of ways as all 10 speakers can give, right? So with above resolution, if the remaining 10 speakers have no objection to speaking, right, with however the order is. So first of all, let's take the cases. First of all, S3, S1, S2 can be a possibility. S1, S3, S2 is possibility. So how can we form this? Is 10C3, we're choosing this 3 speakers, right, and into 2 because we have 2 cases right here. And for the other 7 speakers, it's 7 factorial ways. Yeah, that's it. Thank you.